Hello, my name is Dilnaz, and today I want to talk about space. It's me in my freshman year. At the time I was creating animation out of this Maya. I also wrote a code for calculating planet coordinates via solution of Kepler's equation in Python and build a rocket model. This work led me to create AstroTravel, an application working both on desktop and Android devices, consisting of 3D digital model of solar system with functionality of planet position prediction over time. Calculations were done using Kepler's equation and laws. The starting relative position of planets were taken from NASA GPL database. Resulting data consisting of planets' orbital properties and positions were saved into the database and used to develop application on the Unity engine. By pushing Explorer button, the user can observe surface of planets and read short information. Additionally, AR technology has been integrated into mobile version of AstroTravel. It was done using the before Unity engine. It is how it looks in reality. Another portion of AstroTravel is rocket launch prediction. This rocket flight trajectory prediction program was made on PyQt platform using Python and external libraries. Weather and environmental information on the launch site was taken from GFS Global Forecast System. Newton's laws and force equation had been used to generate rocket's trajectory to later be plotted in 3D plane using Matplotlib library. First of all, we calculated planet coordinates. For that, we used Kepler's equation and derived a centric anomaly, and using efficient iterative algorithm, we get this value and using formula of x and y coordinates of planets in any given date. This result was served in SQL database and compared to NASA. So the algorithm contains calculation of ellipse axes A and B, and iteratively m, which is mean anomaly value, is changed by adding 2b by t, which is orbital period. Next step of our work was creating a physical model of rocket to fully understand what factors will influence its trajectory. As we know, for calculating rocket's trajectories, we should take into account weather conditions. For that, we used Global Forecast System. It's a database that stores information about atmospheric and geological data. Finally, we create PyQt program that takes different factors as input, and as we know, there are three main forces acting on the rocket. They are drag, gravity, and thrust. So in this list we have all values that we use for calculations. Firstly, we include ordinary differential equations, total force F, aerodynamic drag force, and rocket's thrust. Using numerical integration and discretization, we receive different graphs that represent flight conditions. Finally, our application could be useful for rocketry and space flight planning, modeling and efficient storage of data, and study of planetary motion and their influence on the Earth. Thank you for your attention, and as Carlos again said, somewhere something incredible is waiting to be known.